So today we're going to talk about sections 6.2, 6.3, and 6.4, and we're going to start with one of the most generic quadrilaterals we can have, which is a parallelogram. So there's a reason why somebody gave a parallelogram that awful name. It's because it tells exactly what it does. So a parallelogram is a quadrilateral with both sets of opposite sides parallel. That's why it's given that awful name of parallelogram. Two sets of parallel sides, okay? For the symbol for a parallelogram, a lot of times people don't like to write it because it's kind of long. So you can actually sketch a little parallelogram, which looks like a rectangle that's kind of leaning. And that symbol is understood to be parallelogram. So if you're lazy and you don't want to write the word parallelogram, you can draw a parallelogram instead. So for today, the first thing we're going to do is we're going to make a parallelogram. And then what we're going to do is decide what we think is true about it. So I want you guys to take, and I didn't tell you guys to get your straight edge and your protractor out, but if you have it handy, that will probably be helpful to take out your straight edge and your protractor. All right, so I'm going to start using the lines on the grid as a guide. I'm going to draw a pair of parallel lines that are at least 6 centimeters apart. So it doesn't matter where you put these. Just put one, and then skip down at least 6 or so boxes and put another one. And because I made grid lines, now they're guaranteed to be parallel. So I'm going to put arrows on them to show that my lines are parallel. And then I'm going to take my straight edge. I'm going to be using a ruler to do this. So if you have a ruler, this would be fantastic. Or you can count the slopes if you don't have a ruler. But I'm going to lay my ruler diagonally. I don't want it vertically because I don't want it to look like a rectangle. A parallelogram doesn't have to be a rectangle. So I'm going to lay it diagonally, and I'm just going to trace the sides of my ruler. If you don't have your ruler, then just do the same slope on the left and the right. Just make sure if you're going up 4/5, you're going up 4/5 on the other side. And then these sides will also be parallel. So now I've made a parallelogram. By the definition, it's 2 pairs of opposite sides parallel. So it says to label the parallelogram love. We can all use a little love with our parallelogram. So when you guys label your quadrilaterals, you have to go in a circular order. You're going to use this all chapter long. You have to pick a place to start, and then you have to go in a circle. If you start skipping around vertices and you go diagonally, then your love parallelogram will not be correct, like the vertices won't. So I started upper left and I went in a circle, L-O-V-E. Do not go L diagonal O, then V diagonal E. That won't work. Okay, so circular order. So what we're going to do is we are going to measure the 4 sides and the 4 angles of the parallelogram. We're going to put the measurements in the picture, which is what it's telling us to do down here. And then we're going to draw in the 2 diagonals, and we're going to use all of that information to fill in our properties. Some of these you may know already, but we're going to discover it like you've never seen it. Okay? So if you can take and measure your sides, I'll be doing that as well. So measure your sides and measure your angles, and then put all of those measurements into the picture. I'll be doing the same thing. So I'm going to measure the top, and I'm going to do them in centimeters. I just think it's easier to measure. And I'll wait. I won't put my diagonals in there yet until after we talk about these other ones. Okay, so I have my 4 sides and my 4 angles, and I'm going to go down to the bottom of the page where it talks about the different characteristics of parallelograms. Again, you've probably known some of these from when you're little. So the very first thing it says is opposite sides are blank, and this is the definition. Why is it named a parallelogram? And that's because opposite sides are parallel. That's the whole reason why it was named that. But there's something else that are true about opposite sides. They're not just parallel. If you look at their lengths, the opposite sides actually have the same length. So you can also say that the opposite sides are congruent, which you probably knew. Now we're going to go back up to the picture and we're going to look at the angles. So I want you guys to look at the opposite angles. Opposite angles are the angles that are like diagonal from each other or opposite from each other. So I have a 125 and a 125. Those are the same. I have a 55 and a 55. Those are the same. So down here I can say that opposite angles are congruent. Now I'm going to look at a different type of angle. It's called consecutive angles. So I'm going to go back up to the picture and I'm going to look at consecutives. So consecutives are in a row, or the ones next to each other. So 125 and 55 are consecutive. 55 and 125 are consecutive. 125 and 55 are consecutive, and then these two are consecutive. If you notice, they should be supplementary. Now yours might be a little bit off, depending on how you measured, but your consecutive angles should add to 180 each time, and you have 4 pairs of those. So consecutive angles are supplementary. Now, for the next one, we're just going to use our imagination because we didn't draw it like this. But if your parallelogram has 1 right angle, then you probably can figure out that that parallelogram is going to end up having 4 right angles. And then it will end up being what we're going to call a rectangle eventually. Just know if it has 1 right angle, because opposite sides are parallel, it will have 4 right angles. Okay, next has to do with the diagonals. So we are going to take our picture and we are going to use our straight edge to draw in 2 diagonals. So we're going to draw in this diagonal and we're going to draw in this diagonal. And we're going to see what happens with the diagonals. Now, if we weren't videoing this, I'd probably let you mess around with it for a long, long time to try to figure it out. A lot of kids say congruent, but you can tell right now that this one right here is stretched a lot longer than this one, so they are not congruent. So what I want you to do is I want you to measure these 4 little pieces, and let's see what happens. So take all 4 little pieces with your ruler and let's measure them in centimeters. Kind of tight in there. So see, you can probably get the idea as you get going here. So I'm going to circle the measurements I got since I got a lot of stuff going on here. I got 3.3, 3.3, 1.7, 1.7. So what should be happening is these diagonals are actually making a midpoint in the middle because it's making it the midpoint of the long one and the midpoint of the short one. So what we could say is the diagonals are actually cutting each other in half. And the fancy word in geometry for cutting each other in half is bisecting each other. So when you look at these diagonals, they cut each other in half, which we will say is diagonals bisect each other. And they both do it to one another, making a midpoint of both. So that is going to be a midpoint of both. Okay, lastly, each diagonal separates the triangle into blank triangles. Okay, so if I highlight just one diagonal and I look at this green triangle and I look at this green triangle, you probably will notice that the triangles will match each other. So these 2 green triangles will be congruent to each other, and because of that, you have another one, actually not because of that, but you have another one going this way that makes two other congruent triangles. You can think of like side, side, side when we did the congruent triangles, like as a shortcut. These triangles will be congruent by side, side, side. You could use that. But each triangle separates the parallelogram into 2 congruent triangles. So these are your magic numbers. So you're going to see on your vocab, when you go to do your vocab, the magic number for a parallelogram is 1, 2, 3, 4, 5, 6, 7. So we're going to say 7 is the magic number because there are 7 properties that a parallelogram has. So when you see the magic number pop up, this is just magic number 7, okay? So now I'm going to go to your book and show you some examples. So I'm going to show you an example on page 405, and then you're going to try these two. Okay, so on page 405, I want to go over how to get z in this question. So here is your picture, and we are trying to find z. And the reason I'm going over z is it's the most challenging one. So if you guys will look, these two angles have a relationship because the top is parallel to the bottom. So I want you to think of the top and the bottom as being parallel lines because it's a parallelogram. And I want you to think of AIAs, which is a blast from the past. These are alternate interior angles. So if these are alternate interior angles, what do we know about AIAs when our lines are parallel? Well, by the AIA theorem, they match. So we are basically going to take 3z and set it equal to 33, and then solve. You'll get z equals 11. Okay? Now, what's going to happen is after we get done with the notes, you're going to come back and you're going to try these two questions. So go ahead and just circle those. You'll try those two questions on page 405, and then you'll check your answers to those. Okay, now what I'm going to do is I'm going to go to this question, and I'm going to show you what the question says. There's an example on page 406, and so I'm going to show you that, and then we're going to try one like it. So this is on 406 in your book. All right, so let me walk you through this example. It says, determine the coordinates of the intersection of the diagonals of F, G, H, J when these are your vertices. All right, so I want to just point out that they are using a midpoint formula, and that's because the diagonals bisect each other. It gives you a midpoint. So I want to review this midpoint formula with you and show you that that's what we're going to be using. So notice that it's x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So now I'm going to show you how they did that and how you would set that up. Okay, so they gave us 4 coordinates, and what I did is I took RSTU and I put this in a circular order on my paper. So go ahead and write out this parallelogram, and then notice that I put my ordered pairs in a circular order, RSTU. Don't like jump and don't go diagonally when you're naming your parallelogram. Okay, here are the ordered pairs. R is -8, -2. S is -6, 7. T is 6, 7. And V is 4, -2. So the question is going to be this. It's going to say determine the coordinates of the intersections of the diagonals, plural. Okay, so what I want you to do is I want you to take and I want you to draw in your diagonals. You can just sketch them in. You don't have to use a straight edge. And then I want you to put a dot where those intersect. Okay, now based on what we just discovered, these two pieces match, so we're going to tick those. And then these two pieces match, so we're going to double tick those. So what we have now right here is a midpoint. And that's a midpoint because it's the middle of the intersection of where the diagonals cross. It's the middle of both diagonals. Okay, so in order to find that point, which is what it's asking for, we've got to do the midpoint formula. Do you think it matters which diagonal we do? It does not. So I want you to pick one of the diagonals right now, and I want you to do the midpoint formula. The midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So we're going to do the midpoint formula. I'm going to choose RT. Why? I don't know. That's the first one that I noticed. You can do SU. And then we'll compare to see what we get. So I'm going to do RT, you try SU, and we'll see if the midpoint is the same. It should be the same if we do it correctly. Okay, so for RT, I'm going to be taking -8 plus 6. You're going to be taking 4 plus -6, and you're going to divide by 2. And then you're going to do your Y's. -2 plus 7 for me divided by 2. You're going to be doing -2 plus 7 divided by 2, which I guess is the same thing that I did. Okay, and so I'm going to simplify this. So -8 plus 6 is -2 divided by 2 is -1. -2 plus 7 is 5. 5 divided by 2 is 5 halves. Or you can make it 2.5. So now my question is, when you guys did your midpoint for SU, did you get the same thing? And you can write this as 2.5 if you want to. You don't have to write it as 5/2. So the question asked for the intersection of the diagonals, and the intersection of the diagonals is the midpoint, which is why we did the midpoint formula. Okay? Okay, so that's section 6.1, all the properties of a parallelogram and finding the midpoint of the diagonals. So we're going to look at section 6.3 before we stop, and we're going to talk about how we know if something is a parallelogram. So I want you to picture somebody knocking on your door and walking into your house or classroom, and you don't know if it's a parallelogram, but you think it kind of looks like it, but it might be just a quadrilateral. So we're going to run it through a bunch of tests. So these are all tests that you can use to check to see if something is a parallelogram. By the way, it only has to pass one test. Because if it passed one test, that is enough for it to be a parallelogram. Okay, so let's read the tests because the tests are very similar to what we just discovered. If you can show that both pairs of opposite sides are parallel, then we know it's a parallelogram. That's an option. If you can show that both pairs of opposite sides are congruent, then we know it's a parallelogram, which is an option. If you can show that both pairs of opposite angles are congruent, then you can say it's a parallelogram. If you can show that the diagonals bisect each other, then it's a parallelogram. Now, the very last one is very bizarre. It does not sound like any of the other ones we discovered. So this one is the one that is different. If you can show that one pair of opposite sides is both parallel and congruent, then that's enough to be a parallelogram. Okay, I'm going to show you what that looks like. So over to the side, sketch a parallelogram. And if you can show that one set of sides is both parallel and congruent, it has to be the same set. So I'm going to say same set. Then that would be a parallelogram, and I wouldn't have to worry about any of the other tests. Okay, so that's the odd one that's different than the properties that we just looked at. Okay, so now what we're going to do is look at example 1. This is going to be on page 414. So I'm going to show you this. So you're going to pretend like these dudes are walking in the room and you want to know if they're parallelograms. Okay, so what I want you to do is look at this picture right here. If this dude walked into the classroom or your home, would it be a parallelogram? Well, does it pass any of the tests that we just talked about? It has one pair of congruent sides, right? And it has one pair of consecutive angles. Does that match any of the tests that we just talked about? No. So this is not, well, hold on. Oh, they say it is. So hold on. What am I missing here? Oh, I didn't see what they did here. Okay, so here's what they're saying. I had to extend this. So you have 100 and an 80. That adds up to 180, right? These are consecutive interior angles. What's that going to do to these sides if they add up to 180? It's going to make them parallel. And that's the converse, the CIA converse. So now we have one set of sides, both parallel and congruent. So that passes by this last test right here. We have a pair of opposite sides that are parallel and congruent. So let me show you that again. These are congruent, and they're going to be parallel because those consecutive interiors add up to 180. Okay, let's try this one. Do you think 1A is going to be a parallelogram? Well, these sides are congruent, and these sides are congruent. Does that pass a test? Yes. So on your paper, you're going to say that 1A is yes, because, and let's just call this test number 2. It passes test number 2, which is right there. Both pairs of opposite sides are congruent. Okay, let's look at 1B. Do you think that if this one walked into your house, that you would think that was a parallelogram? So we have one pair of opposite angles. Will that make parallels? No. And we have one pair of congruent sides. That is not enough to pass any of these tests. And so we would say no, the tests fail. There is no test that it actually passes. Okay, so we're going to look at example 3 on page 415. Actually, nope, we're going to leave that. You guys are going to go back and do that afterwards. So leave those blank. When we get done, you'll try those 2 questions. Okay, so last question we're going to do is the one down at the bottom. I'm going to do 4A with you, and then you'll go back and do 4B. So this will be the very last one we do. So it says, study example 4 and then complete the guided practice. Okay, so go ahead and draw in this parallelogram, and we're going to label all 4 points. So this is in a circle. It's called ABCD, and so A is 3, 3. B is 8, 2. C is 6, -1. And D is 1, 0. So the question in the book, I'm going to tell you what it says. It says, is this a parallelogram? It doesn't say to find the diagonal midpoint. It just says, is it a parallelogram? So I want to point out that we're going to do this problem by using slope. So there is your slope formula. If you don't think you know it, I would write it down on your paper. It's y2 minus y1 over x2 minus x1. All right, we've done slope before, but I'm going to go ahead and just write in these slopes, and then I'm going to tell you how you determine if this is a parallelogram or not. All right, so the slopes for this problem are, hold on, let me find my, that's not it. Let's see if I can find that. There it is. Okay, so the slopes are going to be -1/5, put that on the top, and then -1/5, put that on the bottom. What do you think is true about 2 slopes that match? They will be parallel. So these are parallel. Now I'm going to give you the slopes of the other 2 sides. So this one is 3/2, and this one's 3/2. What do you think is going to be true about those opposite sides? They're going to be parallel to each other as well. So do you think this is a parallelogram? So you would say, yes, it's a parallelogram because opposite sides are parallel. And I'm going to call that test number 1, which would go with this test right up here, which would be showing that both pairs of opposite sides are parallel. So you would be using slopes to do that. Okay? All right, 4B, you're going to circle, and you're going to go back and try the ones that we skipped, and then check with the answers once you're done.